turn my microphone on. I won't have any stuff from the beginning. The slopes on parallel lines are the same. So they're identical to each other. So they're the exact same. So they're going to be the same. So we look at two lines or two equations of lines. Our equations might look like y equals 1/2 x plus 4 to be parallel. The next line, the next line would have to have the exact same slope. Notice if these slopes are the same, and if I went through and put these two on a graph, let me grab a sheet of graph paper and we'll do it right instead of doing it haphazardly here. If I graph these two, what's going to happen to them? So if I go through and I put my graph together, what would they end up looking like? Well, this one says I'm going to be up at 4. My slope says to rise 1 and run 2. So its slope is going to be going like so, and it's a positive slope, so it should be going in this direction. And if I graph the second one on there, what's it going to look like? It's down at -3. But its slope says to go up 1 and over 2 also. So when I draw it in, what do you notice about both of them? They're parallel lines, okay? And that slope is what made them to be parallel because, again, they're going on indefinitely and they're never going to end up touching each other or crossing each other, okay? So they're parallel. So key thing, slopes are the same. That's the main piece that we learn out of parallel lines. So if we have parallel lines, they don't ever touch. So they don't touch each other. So then, again, key thing here, slopes are the same. We don't care about the y-intercepts because the y-intercepts when we graph can be different with parallel lines, but it's just that slope, that angle that these lines are at needs to be identical in order for those to work. So now, what happens with perpendicular? So if we take a look at perpendicular lines, so what do you know about those? Yeah, they make a 90-degree angle when they cross. Okay, so they make 90-degree angles. So if on here, let's just put a roundabout graph here. So if one line goes this way, and the other line needs to make in here. Now, I wouldn't put it like this because that's not a 90-degree angle, right? Because that's off. So I want to make sure that that is straight up and down and that I get a 90-degree angle where those two cross each other, okay? So they're crossing each other at a 90-degree angle. And so they only cross once. So they only meet somebody once, and they go on and they do their own thing. And so the two never meet again. So it could be somebody that you talk to in the line at McDonald's, and you talk to them just for that time during McDonald's, and you never see them again. Okay? So you two could be perpendicular lines heading in two different directions, and you never see each other again. But you touch once, okay? You see each other once. So it's not like you go on and have never met the person. It's just that you don't see them ever again. So what do we know about slopes with these? So what do you look at this? If I look at this and I'm walking down my little pathway here and I'm walking here, I run across one that's going uphill. So what kind of slope's that? Positive slope. And I'm walking still along here and I see one going this way. I'm going downhill. So this one's a negative slope. So now what do I know is one slope is positive. The other one is negative. So I know that about my slopes. But the thing that this doesn't, yes? Yeah, we're heading there. Yeah. It's the reciprocal of the slope. So if you read farther into this part, you would also know that one slope is positive, one slope is negative, and each is the reciprocal of the other. So what this means is if I have a slope of 1/2, the perpendicular slope is going to be a -2/1. So I take the reciprocal and I also take the opposite sign. So I'm going to flip this thing over and I'm going to get a -2. So therefore, let me show you that this happens. If I have y equals 1/2 x plus 2, and if I have y equals a -2x plus 3, I want to show you on graphing these that I end up with two perpendicular lines. So let me get my paper in here. So if I graph it, then what happens is I'm up at 2. My slope says go up 1 and over 2. So here's my line. This is my first one, which is my positive slope. Then if I graph the bottom one, it says I'm up at 3, but my slope says to do what? What would I do with my slope? Goes down 2 and over 1. So what happens with that is I get these two coming in here like so. And what I have found is I've produced a 90-degree angle in that location. So for these two lines or two equations that I had here, I end up with two perpendicular lines. Okay, so the big key on this whole thing is one slope's positive and the other is negative, but they're reciprocals of each other. Okay, so if you were given the slope of -2/3, what would its perpendicular slope be? So what would its perpendicular slope? +3/2. Yep. That is to get a perpendicular out of those. What would its parallel slope be? So parallel had the exact same slope, so a -2/3. So to be parallel, it would have identical slopes. These match. And this is the opposite sign in the reciprocal. Okay? So what if you had 4/5? And I want to know what the parallel slope would be. So what's its parallel slope going to be? 4/5. What would its perpendicular slope be? But what kind of 5/4? Negative. Yep. One is going to be a positive and the other is going to be a negative, and they're reciprocals of each other. Okay. Very key things here that you get this part down. Okay. How about, let's look at another one here. What if you had this equation, y equals 3x plus 2, and I want to know what its slope is. What's this one's slope? 3/1, okay? And if I wanted to know what the perpendicular slope would be, not perpendicular, parallel. So the parallel slope of a new line would be 3/1. The perpendicular would be a negative 1/3. Very crucial, okay, that we get this part together of what one is parallel and what one is perpendicular, okay? So make sure we get this part, all right? We good there, you think? What do you think? Okay, so far so good? Okay, so now that we know what's parallels and perpendiculars happen to be, let's go to your sheets. So let's take a look at those guys. So now we're going to go to what they give us for information in here. So first we're going to do looking at graphing equations in point slope form. So to graph any equations, yes?
So in this, we're only covering the parallel and perpendicular. We're not covering anything else. It's just straight those topics.
Right. Straight parallels and perpendiculars. Yeah. The question was that we covered other things in here, but nope, they're going to be parallels and perpendiculars based on equations. So we might have an equation of a line and a point. We might have two equations, and then I ask you whether they're perpendicular or parallel to each other, or neither. So we're going to have that type of stuff in here. So as we go and we take a look at these, the equations I need to know is y minus y1 is equal to m times x minus x1. So I need the point slope formula in there. And I also need to know how to get things into y equals mx plus b. And all this is that we're going to solve for y in order to come up with what that is, because we're going to have to do that because I'm going to need to know slopes. Because whenever I deal with these parallels, so parallel, slope's the same. Perpendiculars, it is the negative reciprocal. So that we need to have in there. So when we do those, we have to be careful with that. Okay, so if I read the first statement here, it says find the equation of the line through the point 1, 2 and parallel to this line. Graph both lines. Okay, so what in the world does that mean? So I need to figure out what the equation is going to be of this other line. So first things is parallel, so I know this line or the slopes have to be the same. So the same slope. So I know that piece. We good there? Well, it's going to go through that point, but I need to use this line to do that. So I'm going to take this line, and I'm going to get it solved for y. So if I get this solved for y, I'm going to move minus 4x from both sides. Divide everybody by 5. We good there so far? And I find that this equation, y equals a negative 4/5 plus 4/5 x plus 1/5. So that's that equation. We good so far? Okay. Then what do I need for my parallel slope? So my parallel slope needs to be the same slope. So negative 4/5. And now I'm going to use my point that they give me. And I'm going to create a new line. So what's my new line? Well, I need to use my point slope formula. That's why we practiced it last time. Minus 2 is equal to 4/5 times x minus 1. So y minus 2 is equal to 4/5 x minus 4/5. So now I'm going to add 2 to both sides. And we got those fractional pieces in there. That 2 is going to turn into 10/5 minus 4. My new equation is, oops, I got to have a negative 4/5. That's going to change my value down there. Negative 4/5. I forgot my negative. Negative 4/5 and a negative times a negative one's positive 4/5. So I get a negative 4/5 x plus 10 fifths plus 4 fifths is 14 fifths. So that is my new equation. Not an easy equation, okay? But it still ends up being that part. So let's see if we get parallel lines if I graph this. Oh, 14. The 2, this 2 that's going to move over. This 2 moves over here, becomes 10 fifths. Okay, so 10 fifths plus 4 fifths is 14 fifths. Okay? Yes? No? Yep. Okay, good. Yep, so it gets to become 14 fifths. So that's where I got the 14 fifths at. So now if we graph them, let's see what we're going to end up with here. The first line, we got to do some estimation stuff with it, because I got to graph a fifth. This may be about here. Then I need to go down 4. So 1, 2, 3, 4, and over 5. 1, 2, 3, 4, 5. So that's the first graph. And in Hawks, you'll type these in and then we'll put it on the graph for you. Now the only problem that it has is sometimes it does not put the graph right there for you to take a peek at and look at. This one is a little bit tougher to graph, but they give me a point, so I can use my point, and my point is 1, 2. And so now if I use my slope, go down 4 and over 5, notice that I end up with another graph that is the same. Okay, so they ended up being parallel to each other. This 14 fifths, if I take 14 divided by 5, is 2 and 4 fifths. So up 2 and 4 fifths. Notice it's crossing right there on my line. So I ended up getting it on my line, even though I didn't graph it with that. Then to go down 4 from it, 1, 2, 3, 4, and over 5. 1, 2, 3, 4, 5. And I'm on my line still. Okay, so you graph it either way. Questions with this one? So my key pieces are parallel and taking this and finding my slope. Then I use this to find my other pieces. Okay, so about the next one. The next one's similar. It's the same equation, the same line, but now instead of finding one that is parallel, I'm going to find a perpendicular. It says find the equation of the line through the point 1, 2, which is the same as I had up here, and perpendicular to the line. So if it's perpendicular to the line, I'm still using this same line. So I know from the one up above, y was equal to a negative 4 fifths x plus 1 fifth. But I want perpendicular, so I want reciprocals and opposite sign. So what is my slope for that perpendicular line? Yeah, 5/4. Okay, everybody okay with that? Reciprocal, opposite sign. It's negative, it became positive. Then with my point and my slope, I'm going to go back and do the same thing I did before. So y minus 2 is equal to 5/4 times x minus 1 on my point. So y minus 2 is equal to 5/4 x minus 5/4. Add 2. So I'm adding 2 to both sides. Leaves me with y equals 5/4 x. This 2 becomes 10/4. 10/4 minus, take 5/4 away from it, is a positive 5/4. And so that becomes my equation. Okay? So far, so good? Okay. Then if I graph it, slide that up under there so I have my graph paper down here. Question?
Yeah, I'm confused at why you didn't do 10-4.
Oh, it wouldn't be 10/4, it would be 8/4. Thank you very much for keeping me honest. Yep, then this will make, nope, this one was fifths. This one's 10/5. I just jumped in and put the same thing. So -5 and an 8 makes us 3/4 instead. Yep. Thank you for saying something. I would have had the wrong thing in there. Okay. So if I graph the first one, I'm at 1/5. I go down 4 and over 5. Connect the 2. And then if I graph the second one, I am through the point of 2, 1, or 1, 2, 1 up 2. My slope now says to go up 5, 1, 2, 3, 4, 5, and over 4. And if I connect these two, I will have 2 perpendicular lines. Notice how they came out perpendicular? Because I get a 90-degree angle in here. And 3/4 is right there on my line. So if I went up 5 from there, 1, 2, 3, 4, 5, and over 4, I would be still right on my line. So regardless of how I did that, okay? Once you get your slope and you know it, you can use the point they give you to do your other piece to that, okay? So let's continue on and see what happens with this next piece. This one says, graph the following pair of lines and state the slope. So what is y equals a -3? What kind of line is that? A flat line. So its slope is 0. This one, x equals 2, is what kind of line? What kind of line is that one? That's an up and down one, right? Straight up and down, vertical. What's its slope? Yeah. So what would I have happening with these two? So if I look at my slope, 0 over 1, the reciprocal is 1 over 0, so I have perpendicular lines. And I think we can probably just get by putting that graph right in here instead of putting it on graph paper because it's pretty straightforward. At a -3, I have a flat line. It's -3, down 3. And at 2, I have a vertical line. And so they form 90-degree angles. And of course, they're perpendicular to each other. Okay? Yes or no? Okay. Next one. Graph the following pair of lines and state the slope. Now, when you do this in Hawks, you're going to graph the first one, then you'll graph the second one, and see what happens to them, and see what their shape happens to be. So in the first one, I need to solve for y. So I'm going to divide by 2, and I find y is equal to 1/2 x plus 2. We all good there? Then if I do the second one, I have 2y minus x equals 10. So I'm going to add x. Divide everybody by 2. So I find y is equal to 1/2 x plus 5. So what could we say about these two even before we ever graph them? They're parallel, yes. And we know that because their slopes match each other. Okay, so what's going to happen with these, and we're up at 2, we're going to have up 1 and over 2. This one, I'm going to be up at 5, and we would end up with 2 parallel lines. This one's going to be up at 2, and we go up 1 and over 2. Next one's up at 5, and it goes up 1 and over 2, and you end up with 2 parallel lines with your graphing. Okay. Okay, down to this one. What do you think is going to happen here? What would we need? Well, in reading it, it says find the equation of the line that passes through this point. What kind of point is that? 0,4. It's got a special name. What is that one? What was that? No, it's the y, what's it called? The y-intercept, yes. Yeah, this is the y-intercept. If I know that, I can create my equation really easily. Because remember when we were creating equations in 4.4a, if we had an intercept and we had a slope, all we had to do was plug them in. Didn't have to do any work. So this one, if I can get it solved for y, then all I need to do is plug that point in. I'll have my equation. I don't have to go through all that extra work. So here I'm going to minus 4/3 x. Then I'm going to multiply everything by 1/4, or divide by 4 basically. These cancel. The 4 here cancels, so I have a negative 1/3 x. And here 4 goes into 68 17 times. So what did I need out of that equation? What was the only piece I needed? The only piece I needed was the slope. And since it's parallel, the slope's going to stay the same. My new equation is y equals a negative 1/3 x. Since I have an intercept already, all I got to do is put plus 4. And I'm done. I got my equation. Didn't have to graph this one. It just wants to know what we get for our pieces in there. This clicking or not clicking? Key pieces to look for, parallels and perpendiculars, so that we can end up knowing which one is which. Okay, what's about this next one? Find the equation of the line that passes through the point 3, -2, or 3, 2. It is perpendicular to the line with the equation of y equals 2. Yep, it's going to just be plain x equals 3, because when you look at this slope from that line, it's 0. So the slope's going to be undefined, which means I'm going to have a line going straight through at whatever x is in my point. So I get x equals 3. No work involved with that one. As long as I know those little key things, I didn't have to do much. The next one passes through 4, 3. That is parallel to that equation. So if it's parallel, what would my slope have to be? With a parallel line, my slope is going to be the exact same, and my point is 4, 3. So slopes are my key. So what's my new line going to be? So I use my point slope formula and finish it out. What will it end up being? Y equals 1/2 x plus 1. That will be what my value will be. Good or not good? Okay. Well, next one. My point is -3, 1. Perpendicular. And the line equation looks a little funky there, but what is it? It's the point slope formula all set up. So what piece do I need? What would I need out of it to do a perpendicular? So to get a perpendicular, I need the slope. Do I have the slope in what they give me here? Yep, my slope is right here. 1/2. But to do a perpendicular, what would I need for a slope? Reciprocal and opposite sign. So it's going to have to be a -2. So my slope would be a -2. So if I plug that in, y minus 1 is equal to a -2 times x minus a -3. So y minus 1 is a -2x. These change. -2 times a +3 is a -6. Add 1. And I get that for my final answer. So that's what it would end up being. Yes? No? Okay. I think we got some more here. So we've got lots of them so that we get an idea of what we need to do with this. Oh, take these out and put those in?
Yeah, that's 1, 1, that's the other point for the one line.
Yes.
The other line is -1.
Mm-hmm.
Then just use your slope for the half slope for the 1, 1, and then shoot for the 3, 1. And you find your next point, right?
Yeah, but you got to be careful because you don't use the same slope. Because you got to flip it. Yeah. Mm-hmm. Yep. Basically, same thing. Mm-hmm. Yep. Yep. You're just taking your point slope formula and taking this new slope that you had to find and plugging it in, and away you go. Mm-hmm. But could you leave it without solving it? I don't know. They're probably going to make you solve it. Okay. They won't let you leave it like that, unfortunately. I think they're going to want you to solve it. So you want to make sure you do that and come up with what its conclusion, what its answer would end up being. Find the slope of a line that is parallel and be perpendicular to the line. So all we're looking for is just the slope. So that's kind of pretty easy because all I need to do is solve this for y. -2x plus 5y equals 1. Add 2x. Divide every piece by 5. Y is equal to 2/5 x plus 1/5. So what would be my parallel slope? 2/5. Mm-hmm. And what would be my perpendicular slope? Yep, and you're done. Okay, so that was pretty straightforward. That one's pretty easy. How about the next one? Write an equation for a line parallel to this line through the point 1, 5. Please enter your answer in slope intercept form or standard form. You can get by always using slope form. Standard form is ax plus by equals c. It can be a real pain to get it back into that format. So just always enter it in slope intercept form. That's the easiest one to do. And so what would we end up with? So first I got to find my slope. Minus x. So I want a parallel line. So I want the same slope of 1. So y minus 5 is equal to -1 times x minus 1. And similar, same pattern, same kind of combination that we have there. So same stuff. So if you finish it off, you get -x plus 6. So, and if you wanted this in standard, you would only move the -x back over and have x plus y equals 6. But again, there's no reason to put it in standard form. So just leave it in slope intercept form for those. Graph this one, a review from previous sections, because we can find our point in here. -3 and 3 means they're always subtraction, so it's a -3 and 3 is my point. My slope is a -1/3. And so if you graph this one, and you will have this graph in Hawks. You will not be having to do it on graph paper. But I don't have the graph up here to do that with, So I am at -3. Slope says go down 1 and over 3. So here's my graph. So that's what my graph would look like on that one. Oops, set my point in here. Get it all in there. Kind of shows. Okay. And do you think you have it? There's always 3 more. Pardon? Did I? No? No? Oh. Oops. Down 1. Down 1 and over 3. -1. So I go down, down 1 and over 3.
Starting point is -3. Should be in the other.
Should it be in the other one?
You go back to the next line and positive.
Yeah, I've got to find my, oh, here's my notes. Put the right notes up here. Yes, I did. -3. Thank you. -3 up 3. Yeah, so it should have been up here. So we'll do it in green. So it's a -3 over 3 and up 3. And then I would go down 1 and over 3. So we ended up with a parallel line to what I did have there. So, yep, thank you for catching me. And not getting it where it's supposed to be. Yep. If it were Hawk, she would say, no, wrong. You know, try again. Yeah. So now we got it right. Okay, good. All right. Now, do we need to do more, or are you guys satisfied with what you got? Think you're good? Okay. The last one, this one's a parallel, so we're doing parallel, and then it says find perpendicular, so we've been doing that. We've got our value in here, but it's just a plain old x, so be careful with when you get an x, because we're going to end up with x equals 4 with this one, because there won't be a slope. And then to do the perpendicular, it's going to be y is going to equal 9 because you're going to have a vertical line and then you need to do a horizontal. So be careful with that one. This one is find the equation of perpendicular to this line having the same y-intercept as this line. I guess we do need to do that one because it's kind of a little bit different than the previous ones we've had. So perpendicular, meaning that its slope is going to be different, or it's the reciprocal, negative reciprocal of this one. And this one, we need its y-intercept to make a new equation. So we do have to be a little bit careful with this one. So I got to solve this. So I'm going to move 6x over and get 8y equals negative 6x plus 8. Divide by 8. And I find y is equal to a negative 3/4 x plus 1. So I want a perpendicular slope. So what's the slope going to be? If I want a perpendicular slope, so it's going to be the inverse and the opposite sign, so it's negative, it's positive. And then to get the rest of my equation, I want this y-intercept, so I need to get this thing solved. I'm going to minus 5x divide by negative 4. And I find y is equal to a negative or positive 5/4 x minus 7/4. So I want this slope, or not the slope, this intercept. So my new equation is going to be y equals 4/3 x minus 7/4. So kind of a little different twist on things with that one. So be real careful if you run across one like that. So it's a little different twist. And then finally, this last one, it says determine whether the pair of lines are parallel, perpendicular, or neither. So it's all slopes. So if I get this one, move the 3/4 x over, so y equals negative 3/4 x plus 4. This one's slope is a negative 3/4. This one divide by negative 4 is a positive 3/4 x minus 3/4. So what could we say about these? Are they parallel? No. One's negative and one's positive. Are they perpendicular? No, because it's not a reciprocal. Okay, it would have to have been 4/3 instead of 3/3 or 3/4. So it's not. So this one is a neither. So it is just two lines that are intersecting each other at one point. So there's no comparison or combination with that. Okay, are we good with this part, you think? Okay, let's take a 5-minute break and then 4.5 is looking at domains and ranges. It's not real difficult to do as long as you get definitions down of what domains are and what ranges are. So in 4.5, domains and ranges. And also functions. A function is a group of points or a graph of an equation. So in our functions, the thing is that to be a function, all x's must only have one y. Meaning that if I had 3, 4 and 3, 2, I could not have this as being a function because 3, which is my x value, that's the first piece, is associated with 2 different y's. Okay? So x's can only have one y that they can be connected to. So this is considered not a function because it has that repeat pattern in there. So if we had a whole group of points, 3, 2, 4, -2, 5, -3, and 7, -1, would it be considered a function? So if I go through and I look at this, 3's with 2, 4's with a -2, 5's with a -3, 7's with a -1. Each one has a different y. You notice that? Each x is also different. So each x value in here isn't the same, and each y value is different. So this one we could say is a function. So we can say yes, that it is a function. So we have a function in that case. But again, if they've got some kind of patterns in there, and we'll look at graphs in a little bit of what they happen to be, but if we just start out looking at a whole bunch of points, we get an idea of what's taking place with those. So then from there, we look at domains. Domains are the first term of each point. Or on a graph, it is the x-axis. So the domains are the first pieces of each point. So what would be my domain of this list of points? So if I had 3, 2, 4, -2, 5, -3, and 7, -1, what would its domain be? And we list that in set form. So I want braces. So I'm going to list every x that I have within my points to be my domain. So the domain is any x's that I happen to have. Okay? So that would be my domain of this one. If I had this one, for instance, 4, 2, 4, 3, 4, 6, and 4, 5, I would know it's not a function because x is involved with too many y's. Notice 4 is the same for all of my x's, but they all have different y's. What kind of graph would that be? You looked at that one. Would be a vertical graph. It'd be a vertical graph because what you would find is that all of those points would plot in this format. So my domain in this one is simply 4. So that's all it can be. It can't be anything else because there isn't any new value for 4 or for x. X is all straight 4s across the whole thing. Okay? But it's not a function because it has too many y's connected with it. Yes?
Okay, so if you've got multiples of one number, but at the same fact, one is the domain, you don't have to put four.
Right. Nope. You just list it once. So what the question was is if there's a repeating of a number within your point system, you only have to list it once in your domain or only once in your range, because your ranges can also have duplicates in them once we get there. Okay. So that would be my combination. So if it asks you with a list of points, so what the domain is, you just list the first point or the first value that you see in your point. So that's our domains. And again, it's going to rely on that x-axis, so it's where everything happens with the x-axis, and we'll get to that in a minute too when we have some graphs to look at with these. So the range is the second part of the point, or the y-axis. So we're looking at the y-axis piece with that. So we're looking at the second part of the point, and we are also looking at it as the y-axis. So that becomes our key piece in there when we work with that. So we've got that section and that parts coming together in there for what we happen to have. Okay, so you're going to look at that piece. So if I give you some more points of 3, 2, 4, -2, 7, 2, and -3, 8, I could end up coming up with my range on this, as my range is going to be everything that's at the end. Well, if you notice, there's a duplicate in here, so I write 2, I write -2, and I write 8, and you can put these in order. So that you would have them in the right sequence. I do not need to list that 2 twice. I only need to list it once, okay, because it's part of it. Is this a function? For us today it is. Okay, it's a function. In my intermediate algebra on Wednesday, we're going to say that's not a function because we've got y associated with 2 x's. So we can't have it that way in there. But for us, it's a function because it happens to have that issue where we've got a single x with each y. And so it works that way. But y's can have the same number associated with 2 different values, but it ends up being that. So what would be my domain on this one?
3, 4, 7,
Yep. Or if you want to put it in order, it's -3, 3, 4, 7. Okay. So that would be my domain. So I think we got that of looking at points. Yes.
You said it could only be a function if the last numbers were all the exact same.
No, it can be a function. You mean these last numbers?
Yes.
They can all be different. Okay. Or they can be where, notice I've got 2 2s here. So that's still considered a function for us. Okay. It's a function because the x has only associated with 1 y. Okay. So it's the x term that we're concerned with, and it'll make more sense when we look at a graph because we're going to look at just looking across at the x's and see if we have 2 things in that location or in those spots. So that domain and range end up fitting in there as those 2 pieces. So when you look at just plain straight points, the first term is your domain, the second term is your range, okay? And if you're looking at a graph, this is the domain, and this is the range. So we're looking at x's and y's. So the x-axis and the y-axis are your domains and your ranges. So if you look at it that way, those are the pieces that we happen to have in there. So you want to make sure that you've got some comparisons in there, okay? When you're looking at just plain straight points, it's a little bit more difficult than if you look at a graph. So if we take and we look at some graphs, let's see what we can do with those. So here's some graphs. And we're going to walk through and see what we've got for domains. So when we look at our graph, our graphs that are in here are ones that have a straight line. This is what we've been dealing with so far. So we can say, is this a function? Is every single x associated with only one y? And we could say that because every single point on this line has only one y with it. Notice, if I put a point right here, it's got this x value, but it only has this y value. So it's a function. So we can say yes, that this is a function, okay? But what's its domain? Well, if you look at graphs, these have arrows on the end. Notice how the arrows are there? This means that graph goes on indefinitely in both directions. So I don't know where it ends. It just keeps going and going and going and doesn't stop. So what could I say about my domain? Is there any values I cannot pick for it? So if I look at x, here's x. And if I'm walking along here, and I'm going to start out here, and this line goes on indefinitely up here, every time I get to an x, I hit something on the line. You notice that? So every x that I possibly pick is going to be somewhere on that line. So what can I say out here? Well, we did interval notation in the previous chapter. So what I could say about its domain is I can pick any value I want for x. So its domain runs from a negative infinity to a positive infinity because it's got everything in there that I could possibly pick, right? Now y is the same thing. This goes on out here. So every time if I walk my range line is my x or my y-axis, do I hit something? Every time that I look at y's, I'm touching somewhere on that line, correct? So what can we say about range? Well, range is a negative infinity to a positive infinity. So its range goes from a negative infinity also to a positive infinity, okay? So it goes from one thing to the other so that we have our pieces in there with that. And so we want to make sure that we've got those pieces in there and what's coming up with those, okay? So now, if I look, yes? Yeah, we'll look at some of those. Just hang on a second and we'll take a look at something that will happen with those, okay? If you look at the next line here, this line ends. Notice it's got dots at the end and solid dots. It means it stops right here and it stops right there, okay? So as far out as it can possibly go is right into these locations, okay? So it can't go any farther. No arrows on the end. So what can we say about it? Is it a function? Every x that I possibly have within this distance is only associated with one y, correct? So we could say it's a function. And we can say, yes, it is a function. So now, if I want to look at this and I want to say about domains, my domain changes. Because if I'm out here walking on my x-axis, starting on the left and walking all the way across, what do I see? Well, if I'm right here, what do I find? I find no x's, no x's, no x's until I get right here. Notice right here is my first spot where I happen to find something that it's an x. And if I keep going, I still keep hitting stuff all along here until I get right here. And if I go beyond that, I don't see anything, right? So what is its domain? And we write this in interval notation. So its domain is from out here at a -3, and it goes all the way over here to 1, 2, 3, 4, 5 to a +5, and it ends. I put brackets because it ended, okay? Parentheses when it keeps going on and on, all right? Or it doesn't end at that location. So what can I say about its range? Well, the range, the same thing happens. If I walk y, and this is what you got to do when you're doing these, is you want to look up it, and you want to find out, okay, where do I find the first y? I find the first y here. Then if I go, I keep hitting y's. I keep hitting y's. I keep hitting Y's until I get right here, and I can't hit any more Y's. Everybody see that okay? So what is its range? So it's from a -1 to 5. And that's all it shows, okay? So that ends up being its range and its domain with that one. Think you got that idea with that part? So again, if you just go across, figure out where it stops and what happens to it, then we're good. These get a little bit different down here because they're asking us for domains and ranges there too. Is it a function? Every x that I happen to have only touches one y, right? So this is yes. That one is a function. So what about its domain? These are going to go up here indefinitely. These are going to continue on, so they never end. So what could we say about its domain? Well, everywhere I get, I'm getting an x, right? So its domain is from a -infinity to a +infinity, okay? But what about its range? If I look at its range, I'm down here in y and I see nothing, nothing until I get to here, okay? Then if I keep going up here, what happens? I keep getting everything. I'll go forever and ever up here on getting stuff. So what does its range look like? A bracket, and it's going to be -2 to a +infinity with parentheses, because these arrows means it goes on indefinitely. Okay, that makes sense? Okay. Now what about the next one? Is it a function? Every x has only one y in it, so it is. We haven't had anything that hasn't been a function, so this is a yes. Its domain, walking x's, I see nothing till I get here. I get an x, I get an x, I get an x, 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 no x, no x, no x. So it goes only to there. So its domain runs from 1, 2, 3, 4, -4 to 1, 2, 3, 4, 5. Okay? Yes or no? Okay. If I do range, I'm walking along y, I see nothing, see nothing, see nothing, see nothing. I get here, oh, I get something. So that's where it starts. Where does it end? I keep walking, 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 walking. I keep getting an x up till right here. You following? Okay. So where's that stop at? So it goes from -2 to 7. And 7's included, so I put a bracket. Okay or not okay? All right. As we got some stuff going in the right direction there. Okay. Let's take a look at some other graphs here. These are some others. They talk about what's called a vertical line test. And a vertical line test is where you take something vertical, like my ruler, and you run it across, and you see if you only touch in one spot. So if I only touch every time I move this line across, I'm only touching one space, I know it's a function. So this is a function. Okay? So it's going to be a function. So I know that I've only touched in one spot. If I look at this next one, though, and I'm going along here, I get 1, yeah, and then I get here, I get 1, 2. That tells me something bad's going on, right? It tells me that my x that I'm at that point is associated with more than one y. So this is not a function. Okay, so it will not be a function when I look at that one. So if I did my vertical line test, that won't work. So then if I go back and pick up my domain, what would my domain be on this one? This is going to go on indefinitely that way, and so is this one. So my domain is going to be everything, yep, from -infinity to +infinity, range. This end goes down, so I keep hitting everybody down here, right? But when I get way up here, I stop there, right? So my range is from a negative infinity to 2. Okay? So it stops. So be careful with those. And on this one, domain, walking along on X, I hit to here, then out this way to everywhere. You see that? Because these go out forever. So the domain is from negative 2 to infinity in range. Again, goes out, keep hitting something, hitting something, hitting something, hitting something, hitting something. The whole thing does. So its range is from a negative infinity to infinity. Just remember, if it's got an arrow, it goes on indefinitely. Yes?
Are you writing those with parentheses and brackets?
Yes. These are parentheses. These are brackets and a parenthesis. Mm-hmm.
What's that one over there?
Oh, it should. This is a parenthesis. This one's too a parenthesis. This is a bracket, though. Yep, because it stops at 2. Yes.
So even though it's not a function, we still can find the domain range.
If it asks you,
Okay.
sometimes it won't. I'm just kind of throwing it all and lumping it all in together. But sometimes it doesn't ask you for domain and range. Sometimes it just asks you if it's a function. Yep. So it doesn't always ask you of which one's which. Function or not a function? Not a function. Because the vertical line tests are all at one certain spot in here. And so it's not a function with this one. This one's kind of interesting because its domain is only one number, -3. Its range, on the other hand, is all kinds of different numbers. Okay, so if you go back to that point thing when we had the points listed and we had all those 2s, we could only list a 2. So this is kind of like that. I can only list -3 for its range, or for its domain. Range is all kinds of stuff. How about this one? The function? Well, it matches the vertical line test because everywhere I drop a vertical line, I'm only hitting one y, so it is a function. It's yes. Later on in intermediate algebra, it won't be, but right now it's a function. And so, what is its range? Or domain, I should say. Its domain is all x's, but its range is only limited to right there. Okay? So it's only limited to that one spot. And so we got to watch that part. So that's its only location. Okay, last ones. Got 4 more here. Are these functions? We do vertical line tests. Touches in 2 spots. So as soon as it touches 1 spot and 2 spots, we know it's not a function. But what about its domain? Well, I'm walking along X. Again, domains are X's, so where does it touch? Right there. And I'm hitting something, hitting something, hitting something, then I get right here and I hit nothing else. So its domain is from -4 to 0. And a range. What's its range going to be? So same thing. If I'm walking along here, I hit right here. Hitting, 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 gets to there and nothing else. So its range is from a -2 to 3. Okay, make sense? Okay. Function? Is this next one a function? No. Okay, so domains from here to infinity. We good there? Range is all real numbers, or infinity to negative infinity to positive infinity. And this one down here, function? No. Nope, because the vertical line test touches in 2 spots, so no. And domain from here to here. Range is from there to there. So domain is from -4 to 2. Range is from 1 to 5. Okay, think you got it? It's not hard. It's just paying attention to what your domain and what one's your range. Is that one a function? Yes. Finally. After we had all these no functions, we finally got a function. Yes, because every vertical line test shows it only touches in one spot. So what's its domain? Arrows going out, so we know it goes forever. And range. Everybody down here keeps hitting something all the way down there, but it gets up to here and it stops. So it's negative infinity to 5. You got to count them. And that's a bracket because it hits in that location. Okay, what do you think? Yes? No? Maybe? Okay. But that's basically all the stuff that's in that section. Okay, so hopefully it wasn't too hard. And again, it's just looking at those and going through and seeing what's in there.